Okay, 4.1. So this is a really tough problem. Plug in 1 and simplify. So 1 minus 7 over 4 times 1 plus 4. So negative 6 over 8, which is negative 3/4. Piece of cake. I hope you can figure that one out. All right, restrictions on a variable. So here's an expression, t plus 4 over t minus 12. Are there any numbers that I could plug in that break the expression? And there are really only 3 ways to break an expression. So plug in a number and the whole thing explodes. Okay? Well, when we're dealing with real numbers, the 3 things you're not allowed to do are you cannot divide by 0. Okay? You cannot square root a negative. And then there's one more that deals with exponential equations, logarithmic equations, but you guys don't know what those are yet. So what number are we not allowed to plug in? Well, there are no square roots, so we don't have to worry about that. But the bottom cannot be 0. So t minus 12 is not allowed to be 0. If we just solve for t is not allowed to be 12. Because if I plug in 12, I get 16 over 0. And what is 16 over 0? Well, your middle school teachers were really lazy, and they said it's undefined. Well, I will define it. Okay? So, if I said 10 divided by 2, that means take a 10-foot piece of string and cut it so every piece is length 2. How many pieces would you have? 5. Okay? What if I did 10 divided by 1? So now every piece is length 1. How many pieces do you have? 10. What about 10 divided by 1/2? So now every piece is, so you have a 10-foot rope, a 10-inch piece of string. You cut it so each piece is 1/2 inch long. How many pieces do you have? 20. All right. What about 10 over 1 over 10? Now you have 100 pieces, right? What about 10 over 1 over 1 million? Now you have 10 million pieces. Okay? So, what is that? I should really do this one day. I come in, bring a 16-inch piece of string. I hand it to Cassidy. I said, your job, take this pair of scissors, cut this string until every piece is length 0. How long is it going to take her? Forever. So she's chopping away, right? We all go enjoy our weekend. We come back Monday morning. Here she is, chopping away. And I look and I say, oh, good job. I can still measure those pieces. They're not 0. Keep going. And she cuts away all night long, right? Where are we headed? It's going to take forever, but the answer is infinity. How many 0-inch pieces of string are there in a 16-inch piece of string? An infinite number. Now, will she ever make any of the pieces length 0? No, and eventually she's just going to end up with a bunch of string dust, right? It's just going to look like lint. But you understand where we're headed. The more and more you chop, the shorter the pieces become, and the more pieces you have. So 16 divided by 0 is infinity. So here's an interesting way to look at it. What is 16 divided by infinity? So you take a 16-inch string and you cut it into an infinite number of pieces. How long is each piece? 0. That's cool. Which makes sense, right? let's not do 4. 6 over 2 equals 3. So 6 over 3 should be 2. Right? Isn't that how multiplication and division work? Now, Is 0 times infinity equal to 16? It depends. All right, what about this? What about infinity plus 2? It's just infinity. What is infinity minus 7? Infinity, right? This number is bigger than any number you can think of. So if I come up with a number that is bigger than any number you think of and I subtract 7 from it, it's still bigger than any number you can think of. All right, what about infinity divided by 8? It's still infinity. Infinity is so large, you can't really make it smaller. Okay. Oh, I'm so glad you asked. Let's do this one. Let's say infinity divided by infinity. Well, that's kind of tough. Okay. What is x over x? 1, right? What is infinity over x? If I have an infinitely long rope and I cut it into x pieces, how long is each rope? It's still infinity. Okay. What is x over infinity? If I have a rope of length x and I divide it by infinity, how long is each piece? So I take a rope of some known length and I chop it into an infinite number of pieces. How long is each piece? 0. So this is a bit of a problem. Anything over itself is 1, but anything over infinity is 0, and infinity divided by anything is 1. So which is it? And it can be any of the 3. It just depends on how big your infinity is. Now, there are infinities of different sizes. There is a smallest infinity. There's no such thing as a largest infinity, but there is a smallest infinity. Okay, so Demi wanted to know, what did you ask? What about infinity minus infinity? Well, x minus x is 0, right? Infinity minus x is infinity, and x minus infinity is negative infinity. So what is infinity minus infinity? Could be any of those 3. We also run into the same problem when we do this. What is 0 divided by 0? Well, 0 over 1 is 0. 1 over 0 is infinity. And 1 over 1 is 1. So this could be any of those 3. Now, are all zeros the same size? Yes. However, sometimes we deal with numbers that are so small, they're practically 0. And that's where this comes in. When you take calculus, and I hope you do because it is the most beautiful mathematics ever, you'll figure out how to do that stuff. And it's actually really easy. The idea is complicated, but the practice is super simple. So back to this problem. That's a really good question. So she's saying, is 16 over 0 greater than 1 divided by 0? And the answer is no. So when we talk about infinities of different sizes, we're usually talking about a function that is headed towards infinity. Or if we put this here, what's going on here? Not well. Actually, we do that in Calc 2 sometimes. So yeah, it could be. It depends. You're not going to have, 16 over infinity and 1 over infinity are essentially the same size. But you do end up with equations that are headed to infinity, and you end up comparing their size. And that's something that's really, really common in Calc 2. So I hope you get there. Calc 2 was hard for me. I would be a lot better at it now. I loved Calc 1. It's still my favorite math class I've ever taken. Calc 2 was rough, but I figured it out, and Calc 3 was awesome. So I hope you guys get there. So let's do another one of these. So here, x cannot be -2 because it breaks the equation. And it makes middle school math teachers have a come apart. Okay. All right. So plug in 7. So you're just going to stick a 7 in all of those places. Okay. What if I plug in 7 and I end up with 8 divided by 0? Then we're going to list that as undefined. Is 7 divided by 0 actually infinity? No. The graph would look like this. So here's 7, and the graph would look like this. So is there a point on that graph 7, infinity? No. But it's obvious the closer I get to 7, the closer I get to infinity. But at 7, there is no graph, which is why we say it's undefined. But in practice, it's infinity. Okay? And again, that's something that you'll talk a lot about in calculus. Okay. The denominator of this quadratic factors into y minus 6 and y minus 2. So y equals 6 and y equals 2 are the roots of the denominator. What happens when I plug in 6? Well, this turns into 0, and this turns into 4, and 0 times 4 is 0, and the expression is now broken. So y is not allowed to be 6. Okay, what happens when I plug in 2? 2 minus 6 is -4, and 2 minus 2 is 0. -4 times 0 is 0, and that breaks the expression. So y is not allowed to be 6 or 2. So all you have to do is factor the denominator, find the roots, and those are not allowed to be plugged in. So those are the excluded values. Oh, wrong button. Okay. So Kareem and his wife are each starting a savings plan. Kareem will initially set aside $650 and add $155 every month. The amount A is given by that function. A equals 650 plus 155n, right there. His wife will not set aside an initial amount, but will add $595 to the savings every month. So her function is B equals 595n. The total amount of their savings is just going to be A plus B. So T equals A plus B, which is 650 plus 155n. And then we'll add to that 595n. So that is 650 plus, what's that going to be? So 750. And that function represents how much they will save together. Okay. All right. So we have absolute values, we have square roots, and we have a rational function. So we're going to plug those in. Are there numbers that are not allowed to be plugged in here? Oops. Right there. Some negatives. Would -5 be okay? 18 minus 5 works. Right. So if I did -20, is that going to cause problems? Yeah. Because now I have the square root of -2, which is imaginary. And the only time imaginary numbers come into play in this class is when you have roots of a quadratic that misses the x-axis. or any polynomial really. So it doesn't look like there's an undefined option. So you just make sure that you plug the appropriate number into the appropriate equation. So 3 gets plugged into the f function, -2 gets plugged into the g function, and -4 gets plugged into the h function. All right. What is g of x plus 2? Well, everywhere I see an x, I'm going to replace it with x plus 2. So g of x plus 2 is just -9 over 6 times something squared plus 7 times that same something, and the something is x plus 2. So x plus 2 times x plus 2, x squared, 2x, 2x, 4. So x squared plus 4x plus 4. So -9 over 6 times x squared plus 4x plus 4 plus 7 times x plus 2. Distribute those constants. 6x squared plus 24x plus 24 plus 7x plus 2, nope, plus 14. So -9 over 6x squared, and then 24 and 7 make 31x, and 24 and 14 make 38. All right, that is it.